I am Joshua Patrick. I will be talking about the men who discovered linear algebra and some of their work. Um, the first is Gottfried Leibniz. He was the first to publish his mathematical notation of a function to denote a geometric concepts. He was also the first to develop a system of infinitesimal calculus. He also rediscovered a method of rearranging linear equations into what we now call what we call a matrix. He then could use uh, the equations to manipulate and find a solution. Um, in algebra, the Leibniz formula expresses the determinant of a square matrix. It is symbolized by, in case that isn't visible enough, this is the expression for the determinant of a square matrix. In terms of permutations of the matrix elements, Gottfried Leibniz had a formula in honor of his name, which was the determinant of A, which equals the sigma of the variance. For this is the formula for a n by n matrix, where the SGN is the sign function of permutations in the permutation group, which returns one positive one and negative one for even and odd permutations. Um, Also, another common notation used for the formula is the Levi Civita symbol and makes use of the Einstein summer notation, where it becomes determinant of A equals which is usually for more familiar to physics or psychics. Um, the theorem states that there exists exactly one function where f, the matrix n, times k goes to k, which is alternate multilinear columns such that f of I equals 1. Let f be a function and let A be an n by n matrix called AJ the jth column of A. We gotta write this down. Sorry, you can't see that. So that okay. Also let E of K denote the kth column vector by the identity matrix. Uh, Now we write our matrix AJ to equal the sigma K equals AJ K times N. Okay. As F is multilinear, I'm sorry, next slide. Okay. Also, I found that Leibniz was accused of plagiarism by Newton because the discovery of linear equations was originated from Newton's work. But the only difference was that Leibniz used dx and dy to indicate infinitesimal increments and the independent and dependent variables. But Newton, he used a dot to indicate the same thing. Newton was said to have originally discovered linear algebra, while only Leibniz was the first to publish his work of linear algebra. Um, His theory of calculus allowed mathematicians and engineers to make sense of motion and dynamic change in the world around us. Newton felt that although it was easy enough to represent and calculate the average slope of a curve, the slope of a curve was constantly changing, and there was no method to give the exact slope at one individual point on the curve. So he found a way. Um, this is how Newton's work was different from Leibniz's work. Um, like I was saying earlier, Newton used a dot. He would use y dot we equal dy over dt, such as x dot we equal d of x over dt. But Leibniz, he basically took Newton's work and made it more, I guess you could say, less clumsy looking, I guess. He used d function of f of x with over dx would equal dy over dx, basically. And also, same goes for the integration. When they did integration, Newton, he used x bar. That was how he integrated, or he would put a box around x. Today we see this symbol here, and that's our sum of x, as our sum of x. But in their times, they used it as integration, or Newton used it as integration. Leibniz, being much cleaner, I guess, and more, I guess we could say, put together, he used integration. He used the S, which we now use for integration today. And as of today, we use this same thing for integration. While what Newton discovered, we use his to find the sum of x. Having established the derivative function for a curve, then Newton found that it was easy to calculate the slope of a peculiar point on that curve, just by inserting a value for x. Newton's fundamental theory of calculus states that differentiation and integration are inverse operations. So if a function is first integrated, then differentiated, you can find the original function, just such as you can differentiate the function, and then use that, integrate that differentiation, then the original function is achieved. The next person is Herman Grassman, who was born April 15th. He never worked in mathematics until 1830, and it is also said that in 1830 he found linear, well, not found, but discovered linear algebra. He wrote an essay, The Theory of Linear Extension, a new branch of mathematics. It was 200 pages long. They said that in that he did, however, define a linear transformation, and it was, and he introduced for the first time an analysis based on vectors, including vector addition and subtraction, differentiation, and vector function theory. Um, he defined linear transformation by image vectors for a given basis, and he called this a fraction or a quotient. Um, he symbolized this quotient as Q equals, and that's how he denoted his linear transformation. And that is all that I have for now. Thank you.